A projectile is an object in free fall. We have done in Physics 11 one-dimensional projectiles. You dropped stuff all the time and you said, oh, it's accelerating under the influence of gravity, and you gave that acceleration a lowercase g, and you said g is equal to, what was the acceleration due to gravity? Negative 9.8 units, meters per second squared. That was ignoring air resistance. And now what we're going to add, and some of you did this last year, some of you didn't, a sideways component. Instead of just dropping stuff, we're going to throw stuff. Now that we've learned vectors, we can study two-dimensional projectiles. Here's our first thought experiment. A mass is held at shoulder level and is fired horizontally. So here's my Nerf dart gun. It's on my shoulder. I'm not going to be able to fire it like this, but if I could, and if I fired it exactly horizontally, what do you think would be the most accurate path that it took? Path A, straight down. Path B, path C, or path D? Path A, path B, path C, path D. You know what? Once again, because there are 4 options, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. I'm positive! I'm pretty sure Dueck will make fun of me if I don't vote, so I'm just sticking my hand up so I'm not a loser. Okay? Who says A? Who says B? Who says C? Who says D? Attack or defend. Convince me you're right or someone else is wrong. Yes?
Well, it can't be A or D.
I agree with you.
Because it can't make a right angle.
Okay.
That would be weird.
Yep.
I also don't think it would.
Wouldn't just be weird, it'd be wrong, but yeah.
I would also don't think it would be C because it's flying in a straight line and just at some point gravity starts shifting, which is also very weird. And gravity it should affect it at all times, not just after 5 minutes.
I jokingly call that one, because I grew up on cartoons, maybe you watched the Roadrunner cartoons. When you grew up, the coyote would run off the cliff and stay straight in the air for a while, and then he would realize that he was supposed to fall. That's not how the universe works. As soon as an object is in free fall, it has a downward component. Even bullets, and people don't this because people watch TV. I'm telling you, if you fire a bullet, the split second the bullet leaves the barrel, it's dropping, and it's dropping at exactly the same rate as this tennis ball is dropping. In fact, snipers and sharpshooters who are shooting at targets a long ways away, when you watch the movies are garbage, because they show the sniper doing a long distance shot, and where do they show the crosshairs? Right on the target. He's not doing that in real life. In real life, he's aiming 2 meters above the target, because the bullet's going to, because if it takes a half a second for the bullet to get to the target, in half a second, it's going to fall at least that far. No snipers aim with their little sights and line it right up. That's why it's so tough to be a sniper. If it was just a question of, oh, can I line up the little X? We can get robots to do that. It's a gut instinct, it's distance. Crosswinds, much tougher. Much tougher. B. Now, what if we fired it faster with a bigger initial velocity? The arc might look like that. Or it might look like that. And because you've watched bullets and bullets go so fast, you might think it's straight, but it's just because it's going sideways so fast. This is where we're going to start to say it's got such a big horizontal velocity. Here are the vectors, but I'm telling you the vertical is still accelerating at negative 9.8 meters per second squared. It says defend your answer. We just did. Okay, I hope. In fact, let's take it one step further. Suppose 2 identical objects are held at the same height above the ground. Object 1 is released, dropped, and falls straight to the ground. At the same time, object 2 is propelled to the right, and it also falls to the ground. Which one do you think hits the air first? A, object 1, because it has a more direct path. B, object 2, because it's moving faster than object 1. C, they both hit at the same time. You know what? Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. Who says A? Who says B? Who says C? Understand this is kind of the same question as previous one, because if this starts falling right away, this starts falling right away. But you guys have watched too many cartoons growing up and seen bad physics, or even there's some bad physics in video games sometimes, if you play that. Okay. It says explain your answer using relevant physics concepts. You know what? I got a video. A picture's worth 1,000 words. Put your pencils down. Explain your answer using relevant physics concept. I can't give you the best explanation yet. So I'm just going to leave that blank. And then later on at the end of this lesson or at the end of the next lesson, you might even just glance at this and say, oh yeah, I know how to answer this. But I'm going to give you a one-word hint. Your hint is going to be the word components. And this is our phrase that I'm going to be flogging to death today. What this demonstration shows us is that the horizontal and vertical motions, components, of a projectile are independent. How fast you launch it horizontally can't possibly, Clay, you going to make it? Because those eyes were looking like they were shut for a while. Okay. Kiowa, you're good? Yeah. Okay. No matter how much horizontal velocity I give something, it's still going to fall at the same rate as something that will drop. In fact, Mythbusters, a few years ago, one of my favorite TV shows, about 4 years ago, they managed on TV to do it with a bullet. They rented a long hanger, they fired a rifle bullet, they noted where it landed, then they reloaded the rifle, and they set up a circuit so that they had just a stationary bullet hanging here so that when they pulled the trigger, the stationary bullet dropped and you saw the rifle bullet come into frame and they hit it exactly the same time. Okay? The physics works. Yeah?
But this disregards if we didn't know, right?
And we're also ignoring air resistance, and we're doing this. We're not doing orbits or anything like that.
It should be fast enough for, you know.
That's later, yeah. Orbits. Yeah. Okay? So let's talk about the components. Vertically, your acceleration, you already know. What's the vertical acceleration due to gravity? Negative 9.8. What about horizontally? What's the acceleration horizontally? Well, let's see if you can figure it out from observation. What's the key idea? What is the horizontal acceleration of any projectile? So I don't want to write that out. That's too much writing. What's a good letter to use for acceleration? A. What's a good abbreviation for horizontal? We use a certain letter of the alphabet that comes late in the alphabet, the same way as we use a certain letter of the alphabet for vertical that comes late in the alphabet. So I'm going to say this. If you really want to put meters per second squared, you can, but it's 0. You know the most common mistake for the rest of the unit? Kohei, it's going to be kids want to put a negative 9.8 in for a horizontal. The rant that I gave you guys last day about don't you dare put a horizontal into a vertical or a slanty into a vertical or a slanty into a horizontal. The vectors have to match. Let's keep going. If we look at a stop action or a strobe picture of a projectile, you'll find that it's moving at a constant horizontal speed. Notice the horizontal distances that it's traveling are identical, but the vertical distance each time is increasing. Why? Which way? Can you give me that as a letter that I might want to use that would imply vertical? Because I asked you to. Why? Because I asked you to. Well, I'll never get tired of that joke. Vertically, you have an acceleration. Vertically, you would expect the distance over each second to change because it's speeding up in a negative direction, but it's speeding up. We need to start thinking two-dimensionally. We need to now, when something is moving slanty, like a projectile, realize it's not moving slanty, it's moving horizontally a certain way, and it's moving vertically another way, and I can split them up in my brain. Vx is constant. In fact, sorry, I'm going to leave that as Vx is constant. Vy changes, and for Vy, so constant, you can say Ax is 0. Here you can say Ay is negative 9.8. Give reasons for your answer. There. What does this mean then? If you give me a projectile question, the first thing I'm going to do before I do anything else, components. Show you what I mean. Oh. Constant Vx demo MIT. What's that one? Example 4 says, consider this stop action picture of a projectile below. At each point along the path, indicate the velocity component. So when you launch it at an angle, there is a horizontal component and there is a vertical component. Right here, what can you tell me about the horizontal component of the velocity compared to when we started? Is it bigger, is it smaller, or is it the same? Why? Because horizontally, what's your acceleration? I need to pound that into you folks. In other words, if you wanted me to draw a vector of Vx, I would draw about the same length line as I see down there. And you know what the horizontal component is here? It's the same. And you know what the horizontal component is here? It's the same. And you know what the horizontal component is here? It's the same. They're all the same. It never changes. Which one does change? The vertical component. So looking at this second strobe right there, do you think the vertical component of the velocity would be bigger, smaller, or the same? When you throw something up on the way up, what happens to its vertical speed on the way up? The vertical component would be little tiny compared to the great big one. In fact, if you wanted the resultant, it would be connecting those two tip to tail. I'm not going to do that. I'm not that interested in the resultant. I'm interested in the components. What about at the very top for a split second, although you're still traveling horizontally, at the top for a split second, how fast are you traveling vertically? Wait a minute, Mr. Dueck, doesn't that mean you stopped? No. Vx, there's still a horizontal component. You're still moving sideways. Constant the whole time. Here, this would be Vy on the way down. And because this is at the same height as that earlier strobe, I think Vy negative would be the same length as Vy positive over there. And when we hit the ground, I think Vy on impact would be the same length. What goes up must come down. It'd be the same speed, the same magnitude, the same length as the way I launched it. So A says, at each point of the path, indicate velocity components. We did that. What happens at the top of the trajectory path? Vy is 0. What can be said about the projectile right when it's about to hit the ground? Here's the initial vertical velocity right there. What can you tell me about the final vertical velocity compared to the initial vertical velocity right when we're about to hit the ground? I got to be fussy, almost the same, except Spence. In other words, if you launched it upwards with an initial vertical velocity of positive 12 meters per second, you know what you're hitting the ground at? Negative 12 meters per second. What goes up must come down. That's from the ground. What about from a cliff? And by the way, launching from an angle off a cliff will be the toughest to deal with in this section. It says indicate velocity components. So we're launching at an angle. I would actually then, in my mind, break this up into horizontal and vertical. Draw something like that. Let me make that a bit bigger for people in the back. It's really, again, get away from thinking that it's moving slanty. It's not. Mostly, okay, fine, it is, but I never think of it that way. I think of it as moving horizontally at a constant speed, vertically at a changing speed. At the top, I tried to draw Vx the same as I drew it down there, because Vx doesn't change, because the horizontal velocity doesn't change. At the top, how big should I draw the vertical component? I'll make a little note here. In other words, that is actually all of the velocity. That happens to also be the resultant this time because there's no Vy to add to it. Okay. What about even with launch? I would still have the same Vx. Which way would Vy be pointing? Downwards. How big would Vy be compared to when we left the cliff? The same. And then Clay, what were you going to say? Negative. I'll just do that. By the way, I don't need to put a negative in front of it because the arrow points negative. Yes? And then as it keeps falling, what's going to happen to the magnitude of Vy? So I did say what goes up must come down. That trick only works, Kiowa, from the ground to the ground. If you're launching off a cliff, you're going to hit the ground harder than when you started. Okay. So even with launch, Vy final equals negative Vy initial. Or Vy initial equals negative Vy. They're opposites. Don't care which way you put. I guess you, okay, fine. You guys are like, shouldn't you put the negative with that one because it's down? Fine. All I'm saying is they're opposites of each other. Same magnitude. Just before impact. There's Vx. Same length always as the first one that I drew because it's not going to change. How long would I draw Vy? Longer than Vy initial? Shorter than Vy initial? Or the same as Vy initial? Way longer. In fact, the result, there's Vy. Let's call it impact. The resultant when it hits the ground would be that slanty thing there, I guess, if I really wanted to add them tip to tail. Again, key ideas. Horizontal speed is constant because Ax equals vertical speed is changing because Ay equals Dale. Not Dale. I did it again. Kevin. And that's constant as well, but so the acceleration is constant, which is what gives you a changing velocity. And again, horizontal and vertical motions are They don't affect each other. Don't you dare put a horizontal expression into a vertical equation. Don't you dare put a vertical expression into a horizontal equation. That's bad physics. Let's try one. Example 7. Alex and Alex, if you give me a projectile question, first of all, most of the time I'm trying to find time, no pun intended. Most of the time you're finding time. If you know the time, the question's going to fall apart. Or once you find the time, I'm telling you, the question's going to fall apart. Sometimes it'll be easy to find time. Sometimes, cliff at an angle, it'll be yucky to find time. No matter what, I always start out with what I call a little T-table. Why do I call it a T-table? Because it looks like the letter. And I label one side horizontal, I label one side vertical, and I do even more than that. There's something, I can't call it a no-brainer because you have to know, Travis, some physics. But once you know the physics, here's the no-brainer. I do my T-table, I put an H for horizontal, I put a V for vertical, and then I go AX equals 0, AY equals negative 9.8. As long as you're on Earth, that's not going to change. The rest will vary from question to question. So let's look at this. It says find the flight time and find the range of the projectile. First, by the way, what I'm really doing, remember I gave you the acronyms DULP and DFIC? We already got the picture. DFIC said list your data. That's what the D stood for. I'm doing it as a T-table. That 20 in the picture, see it? What is it? Well, it's meters per second. It's a velocity. Which velocity? Spence. What's my vertical initial velocity? By the way, I'm going to put a little y right there, a little y right there to really, really, really emphasize direction. I'm going to put a little x right there. I typed this and I forgot to change it. I need to go back. When I handwrite it, I really go, because again, the biggest mistake, Kiowa kids put a horizontal into a vertical. I figure if I can just emphasize x's and y's, that might help my brain keep from tripping on itself. Okay. Hey, what's the initial vertical velocity? If you launch something horizontally for a split second, right when you leave the cliff, how fast are you traveling vertically? I heard it. By a split second, I mean like 1 femtosecond, like really short. But it is 0. That bugs kids. Common mistake number 2, Dustin. Kids want to put that 20 in there. Wait a minute. What direction is that 20? Horizontal or vertical? Don't you dare put it into a vertical! What else has the diagram given me? This. A displacement. Is that displacement, look at the picture, vertical or horizontal? Okay? So I'm going to put it in the vertical column. They could have given me this displacement, and I would have put it down here. They gave me this one. This is wrong. Why is that wrong? Nope. And by the way, I don't know if you caught, I never said this was a distance. What did I say it was? Are you ending up above or below from where you started? How would I indicate that my displacement? Common mistake number 3. Kids forget the negative. In any projectile question, when you get to here, you're going to notice 2 columns. In one of the columns, you'll have 2 things. In one, you'll have 3 things. You're going to solve this in the column that has 3 things. We're going to solve this one vertically. If they'd given me the horizontal range, I would have solved it horizontally. We're going to solve this one vertically. We're going to solve this one vertically. I'm going to extend this line a little bit, like that. What did I tell you that we wanted to spend most of our time trying to find? I'm looking for an equation that has V initial, A, D, and T in it. There is one. Yep. And I'm going to go VI because that's what I'm kind of used to, plus a half A. But you know what? I'm even going to be fussier. Look up, look up, look up, look up, look up. Are we vertical right now or horizontal? I'm going to remind myself, vertical, vertical, vertical. Why didn't I put a letter Y on time? Scalar, I don't care. But you know what? That little bit of drawing those Y's is good bang for my buck. It's because that's by far the most common mistake. Are any of these 0? Oh, thank God. By the way, when VI is not 0, it's a quadratic, and we have to use the quadratic formula. There's just no workaround. That's a lie, there is. But anyways, I'll show you that. So if I hear you correctly, Jason, what you're really saying is dy equals ay t squared, and instead of writing a half, can I write a 2? Jason, what are we trying to find? How would I get the t by itself? What will I do with the 2? What will I do with the ay? What about how do I get rid of squared? Is that okay, Dustin? I think it's going to be this. You're going to get t squared equals 2d over a, vertical, vertical. How to get rid of a squared? Square root. It's going to be 2 negative 9.8. Put your pencils down, look up. Remember how most of you missed that this was negative? The nice thing is, on this line, there is kind of a built-in error check, because if you put a positive 50 instead of a negative, you would go 2 times 50 divided by negative 9.8, and then you would say, I want to square root that, and the universe says, I can't do what you're asking me to do. So if you get something weird, go back and check your signs. Maybe you missed a negative that should have been there somewhere. Or something else, but that's my first inkling is something below me and I forgot. So, the nice thing is there is that little built-in error check there. Two times negative 50 divided by negative 9.8 square root. Now, my final answer, I would go to 3 sig figs, 3.19, but I'm going to carry a few more because I know, Manny, I'm going to be using this to find other stuff. So I'm going to say this. T equals, I'm going to go 3.1944, 5 sig figs. And then I'll go equals 3.19 seconds, and I'll put a box around it because that's an answer. Up here, look up for a second, folks. Let's call this part A. Let's call this part B. And I'll even put a little tiny part A right there. Yay! Components, components, components. How many seconds did it take me to hit the ground? 3.1944, blah, blah, blah. Why is that so handy? Because if that's how long I was falling for, isn't that also how long I was traveling sideways for? In other words, I think I can now say yeah? What were they asking me to find in part B? The range, look at your picture, the range, that's, I think, a displacement, horizontal or vertical. You know what? They're asking me to find dx. Now, I couldn't do that before because I only had 2 pieces of information there. But now that I moved time there, do I now have 3 pieces of information there? Well, I can find the 4th. I'm looking for an equation that has VI, A, D, and T in it. This, oh, you don't say. Wow, Mr. Dueck, that's kind of handy. Are any of these 0? By the way, if you really look closely, you'll notice I didn't bother putting an initial. Why not? Why didn't I bother putting an initial? Because if you're not accelerating, your initial is your final, is your middle, is your constant speed. So I was so lazy I didn't even bother putting the I on there. What am I trying to find? dx. Do I know Vx? 20. Do I know time? 3.1. No. In fact, you know what? I'm going to use my answer button. Hopefully you had a good physics teacher who went on a rant about getting a good calculator. First couple days. So B dx is going to be 20 times 3.1944. That far. Is this a final answer? Then I'll go to 3 sig figs. 63.9. Units, meters. Hey, that's an answer. I'll put it in a box. Mr. Dueck, you have part B, then followed by part A. As long as you label things clearly, I'll find it. I mean, you could make an argument that I should have worked. I find it easier to do my verticals on the vertical column, my horizontals in the horizontal column. Sorry. Wrong button. Up to, there we go. Tried to pause the video for a second there. Ready so far? Did you need something or? Okay. There you go. I guarantee you on your test there will be a cliff horizontally. And either I'm going to give you the vertical height, find time, find range, or I'm going to give you the range, find time, find vertical height. You're going to do both in the homework. I guarantee you on your test it's going to be projectile on the ground at an angle, a little tougher. So example 9 says find time to top, total flight time, and the range. Why is this one so much tougher? Slanty. Although it's not any tougher, because I've told you that you can think of a slanty as moving horizontally and vertically at the same time. Do you remember the key word that I threw up earlier? The end letter C? We're going to break this into components. If you give me anything slanty, I refuse to deal with it. I will break it up into horizontal and vertical components. Hey, why did I put an initial on the vertical but not bother on the horizontal? Horizontal's not changing. I'm using every subconscious chance I can to reinforce, don't get these mixed up. Vertical is going to change. Horizontal is not. That 100, opposite, adjacent, or hypotenuse? Hypotenuse, and again, Kohei, however you want to do it, as long as you get the right answer, I'm fine. He was teaching me Sokotoa in Japanese yesterday. It was very cool, but I forget the words. Vy, opposite, adjacent, or hypotenuse? What about Vx? I want to find, and I'm going to do this before I go any further, Vy initial and Vx. Let's find Vx first. Which trig function? Cos? How would I get the Vx by itself? Okay. By the way, if you have just in this short time already gotten good enough at your trig that you can go straight to your calculator from this line, in your homework, go ahead. In our notes, I'm going to write this just so that when you're studying, in case you blank out, you know what the heck we did. $81.915, blah, blah, blah. Psst. I'll carry some extra sig figs because that's not my final answer. I would have drawn a little t-table, although I already did for you. Oh, what else did I say were no-brainers? What were two things when you were doing horizontal and vertical that you could do right away? What's the horizontal acceleration? What's the vertical acceleration? Let's find Vy. Which trig function? Sine. Vy initial over 100. How would I get Vy initial by itself? Times by 100. If you have a good calculator, hopefully your teacher went on a rant about the importance of a good calculator, you might find that you can just backspace and change the cos to a sine, because all the rest of the numbers are the same. And I get 57.358. My rule of thumb is if I know I'm going to be using this stuff later, I go to 5 or 6 sig figs. That keeps me good for 2 or 3 sig figs in my final answer. Mr. Dueck, yeah, you said we needed 3 things in a column for us to, true enough, solve. Well, what does A want me to find? Let's do that first, okay? Time to top, would that be vertical or horizontal? When I say the word top, does that suggest sideways or up down? You know what? I'm going to solve A right there under vertical. I know you might want to write it over on the left. Be organized in your physics, not in your English writing. I'd rather have that. Normally I would DULP, I already got a picture. I would DFIC, I already listed my data. What else do I know? Do I know anything at the top? Sadly, no. A is not 0. A is negative 9.8 meters per second squared. And that's another one. A lot of people think gravity doesn't magically turn off. Gravity is acting on the projectile the whole time. But he's close. He's on the right track.
Did you do the Z thing?
Nope. I heard. You did, huh? At the top, I got to be fussy. I think you thought it right, but you said it wrong. You said V final is 0, and I need a direction. Look. Vy final. Because you know what Vx is? I can tell you at the top, 81.915. You know what Vx is 1/3 of the way through? 81.915. You know what Vx is right before we hit the ground? Everybody, 81.91, because that's not going to change. So when you said V final is 0, I want you to start always thinking components, always thinking in 2 dimensions. V final, vertical, Vy final is 0. Why is that so helpful? I think I can find T. I'm looking for an equation that has A, V initial, V final, and T in it. I think it's the first one, is it not? And in fact, this one I'm so good at, I think we can get the T by itself right now. What would I write? T equals Vy final minus Vy initial over Ay. I know it says V final minus V initial. I'm going to reinforce vertical, 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 vertical. the last thing I want to do, and I see this, I see kids drop the 81.915 into this equation because they don't realize that Vy final is 0, but they know there should be something. I gotta put something. No, don't put a horizontal into a vertical. That's a sin. 0 minus 57.358. Uh-oh, am I going to get a negative answer? I don't want to. Divided by negative. I'm going to get a negative divided by negative. Time stays positive. Whew. And I like that because the fact that the negatives cancel, it suggests, Kiowa, the universe is okay with my physics because I know time is supposed to be positive. How long to get to the top? Sorry?
5
Oh, hey, I have this number still here. I'm going to go 0 minus, answer button. Hopefully I've gone on a rant about the usefulness of getting a good calculator. Divided by. So 5.85?
Yeah.
Okay. I'm going to write down probably 5.8528 on the off chance that I need, and then I'll do the rounding off. So I'm going to write 5.8528, and then I'm going to say equals 5.85. I'll attach the units. I'll put a box, and Mr. Dueck will clue in that that's the one that you want me to mark. Cool. What's B want me to find? Holding on to my pencil. Good projectiles, gravity. What's B want me to find? Sorry? Total flight time. We found time to top. Heard somebody, isn't that what we just found? We found time to top. There is a very easy way to find total flight time for this question. Huh? I thought I heard someone say it. Yeah. Or if I really times it by 2. Now, that only works because are we starting on the ground? Say yes. Are we ending on the ground? Then that'll work. What if we were going off a cliff? That trick doesn't work, sadly, and that's why the cliffs at an angle are the toughest. But yeah, B. I want to be organized with a minimum of writing. I'm going to go T total so that I don't get this T mixed up with the other T. Or you could label the other one T top or I don't know, something like that. It's going to be 5.8528 times 2. By the way, there is another way that you could do it. What if you hadn't done part A already and you wanted to find the time of flight and you didn't want to waste your time, no pun intended, finding time to go to the top? Look up. I'm going to write or what's Vy final when you hit the ground?
0.
No, that's after you hit the ground, Captain Obvious. Okay, when I say when you hit the ground, I mean that one, not afterwards. You should all be able to tell it to me by looking at our listed data right now. I gotta be fussy, not 57.358. Spencer, what? You could also use that, and I think if you know that, Kevin, you can walk to this equation here, VF equals VI plus 8, VY minus VF minus VI over A, and you'll get total time of flight in one fell swoop. And I would do that because I'm lazy. I would do that if they hadn't asked me part A. I would do it this way because why would I want to do extra work? Anyways, regardless, 11.7 seconds. And just to convince you that I'd be okay, negative 57.358 V final minus 57.358 V initial divided by negative 9.8. As I said, you get the same answer. The last few decimals, because I rounded off, are different, but you get the same answer. There is another way you could also do this, and that has to do with your vertical displacement. How high were you when you started? 0. How high are you when you finished? 0. What's your vertical displacement? 0. You could actually let dy be 0 and use the equations with d in them. That's not a good way. It works! It's just longer. Especially because the one is the quadratic, and we avoid that. We're going to finish with part C and then pause. What did part C want us to find? Range, horizontal or vertical? Well, then I'm going to do that here. Wait a minute, Mr. Dueck, you only know 2 things. So I want to find the range. Or do I know 3 things here now in this column? Pause for a second. What else do I know? What else do I know? What? Which time am I going to use? The 5.85 to the top or the 11 point for the whole flight? So you're saying that I think I want the whole, because I want the whole shebang, the whole distance. So I'm going to use, I'm going to write over here t equals 11 point, what was it? 706. I'm looking for an equation that has A, V, D, and T in it. Dale is saying, Mr. Dueck, I think this one. Is that what you were saying, Dale? Except I'll remind myself, horizontal, horizontal, horizontal. Are any of these 0? Horizontally. Cool. Oh, this is straight plug and chug. I've already got the D by itself now. The range is going to be 81.915 times 11.706, or you can use your answer button. 81.915 times, oh, that would have been a problem, forgot the decimal. 81.915 times that. I've rounded off, so my decimals over here will be different, but I think we all get 959 to 3 sig figs, yes? No matter how we round it. Units, meters, final answer, put a box around it. Clearly you can see we're going to be doing more, we're going to be doing cliff at an angle next, but if you want to get a head start in the homework, and I'm going to pick up with this on Tuesday, see if you can handle number 1, which is horizontally from a cliff, 4 different questions. You might be able to fit all that on the page. You might have to do this on a separate piece of paper. And see if you can handle number 2, angle from the ground. Cliff at an angle and all this stuff we're going to tackle later. So I'll pick up with this when I see you folks again on Tuesday.